Hello. Imagine you run a 5-mile race where you start slowly and gradually increase your speed. At the 1-mile mark, you're running exactly 1 mile per hour. At the 2-mile mark, you're running exactly 2 miles per hour. And at the 3-mile mark, you're running exactly 3 miles per hour. In fact, at any distance X, you're running exactly X miles per hour. This is one of the ways a beautiful number enters mathematics. Whenever the rate of change matches the amount you already have, whether it's speed matching distance, or money growing according to how much money you have, or a population growing according to its size, a specific number appears. And mathematicians call this number E. Like pi, E is irrational. That means its digits continue forever without repeating. What fascinates me about E is its unusual combination of beauty and mystery. If you study to become an actuary, you will find E everywhere. In interest theory, probability, risk models, survival models. We see it so often, we stop asking what it is. It's a bit like gravity, always there, always doing its thing, part of the fabric of the world. But when I stop using E to solve problems and start asking what E actually is, I realize how remarkable this number really is. Now, one reason I find pi beautiful is that it comes from a perfect curve, a circle. Yet, we can express it exactly through beautiful patterns built from whole numbers. And in a similar way, E emerges from the idea of continuous change. And yet, mathematicians have discovered countless beautiful ways to express E using simple patterns of integers and sums and products and fractions. If you're interested, I encourage you to look up formulas for E just to notice a few. Why these patterns exist feels like a mystery. Michelangelo once said, David was already in the marble, and he simply removed what was not David. And to me, beautiful math can feel the same way. Mathematicians do not set out looking for E. Yet, as they explore new ideas, E just keeps showing up, almost as if it had been there all along. Here's just one example that I recently encountered. Generate random numbers between 0 and 1. Keep adding them until the total exceeds 1. And then start over and count how many numbers it took. Repeat the experiment thousands of times. And here's the kicker. The average count approaches E. Now, I find that interesting because why should a number connected to growth and change suddenly appear in a game of random numbers? And yet, there it is, a tip of the iceberg of what we call E. Just as pi is the mysterious number behind circles, and the sine curve is the beautiful pattern behind waves, E is the mysterious number behind growth and change. And the more time I take to slow down and notice where E appears, the more I find myself wondering why this one number keeps showing up. And the more I wonder, the more I am drawn to the beauty of it all.